All right, welcome to The Explainer. Today we're going to dig into this really fascinating paper that lays out a powerful new way of thinking about how our minds actually work, how they predict, plan, and somehow make sense of a world that is just overwhelmingly complex.
Okay, let's kick things off with a simple little puzzle that actually shows something pretty profound about your brain. If you saw a string of characters like A, B, C, and another one like 12, 13, 14, but the middle character in both was the exact same ambiguous shape, what would you see?
Yeah, you almost certainly saw it as the letter B when it was surrounded by letters, right? And then just as easily, you saw it as the number 13 when it was next to other numbers. Your brain didn't even skip a beat. It just knew. The symbol itself didn't change, but your brain figured it out in a flash.
So that little bit of mental gymnastics, that magic trick your brain just did without you even noticing, well, that is the key. It's the key to understanding one of the brain's biggest superpowers, its incredible ability to use context to figure out what's important. Now, that ability to just know what's relevant, that's the solution. But before we get to the how, we really need to appreciate the massive, massive problem your brain is solving every single second of the day.
You know, think about a chess master. They're staring at the board and they're completely tuned in. They're ignoring the temperature in the room, the sound of traffic outside, even what they had for breakfast. All of that is just noise. Their brain filters it all out to focus only on the game. It just knows what's relevant.
And this isn't just a challenge for us humans. In the world of artificial intelligence, this is a huge classic problem. It's called the frame problem. How do you teach a machine, or a brain for that matter, what to pay attention to and what to ignore when there's an almost infinite amount of data flying around? And this is where the paper we're looking at today comes in with a really elegant idea. The authors basically say the brain solution is context. Just think of it like a spotlight that your brain can aim, shining it only on the information it needs for whatever it's doing right now. Okay, so how does the brain actually build this spotlight? And how does it know where to point it? Well, the paper suggests it organizes everything it knows about the world into this really neat three-part structure. So let's break down how this model is built, from the very bottom all the way to the top. This structure is what lets us go from just basic sensory info to, complex thoughts and plans. Okay, so at the very foundation, we have what the paper calls concepts. Think of these as the absolute basic building blocks of your reality, the Lego bricks of your mind. Mug, table, sharp, sliceable. These are the fundamental properties of things in your world. All right, one level up from that is where things start to get interesting. This is the events layer. Your brain takes those concept bricks and starts snapping them together into little actions or scenes. So it's not just a knife and bread anymore. It's the event of a knife slicing bread. And then at the very top of the pyramid, you have contexts. This is the master layer, the big boss. A context like making breakfast is like flicking a master switch. It instantly activates all the relevant events and concepts you're probably going to need. Knives, bread, slicing, spreading, mugs, coffee, and at the same time, it keeps all the irrelevant stuff like playing chess switched off. So here, you can see the whole hierarchy laid out. It's really brilliant. The context sets the stage. It tells your brain which events are likely, which concepts are important right now. It is just an incredibly efficient system for organizing everything you know. Okay, so that's the theory. It sounds neat and tidy. But how does a system like this actually handle the messiness of the real world, right? Where things don't always go according to plan. Let's walk through a super simple example from the paper. So imagine you're in that making breakfast context. You're grabbing the bread, the peanut butter, everything's fine. But then you grab the jelly jar, and it's stuck. It won't open. Now, your brain doesn't freak out. It just instantly, seamlessly switches context. The big picture of making breakfast fades into the background, and this new, very specific subcontext, opening the jar, takes over. All your brain power, all your focus is now on events and concepts for that one problem. And then, once you get it open, boom, you switch right back to making your sandwich.
Okay, so we've got the structure, right? Concepts, events, and contexts. But what's the engine that's actually running this whole thing? What makes it go?
Well, the paper connects all of this to a really powerful idea in neuroscience called active inference. And this isn't just some small detail. It's the core operating principle that drives everything: how we see the world, how we learn, and how we act. So what is active inference? Well, in a nutshell, it says your brain is basically a prediction machine. All day, every day, it's making guesses, predictions about what's going to happen next. And its number one job is to minimize surprise. That's the gap between what it predicted and what actually happens. So every single thing you do, from moving your eyes to wrestling with that jelly jar, is ultimately an attempt to make the world match your predictions, to make it less surprising.
And this whole prediction process is happening on two different timescales at once. Over the long term, we're talking your entire life, your brain is slowly building and tweaking that three-layered model of the world. But in the short term, in the here and now, it's rapidly using that model to figure out what you're seeing and what you should do next.
All right, so let's tie this all together. We have this three-layered structure, and it's run by a predictive engine. So what? Why is this model so important for understanding how our minds work?
Well, for one, it gives us this really elegant solution to that massive frame problem we talked about. It uses context to just filter out all the noise. It also explains how we can plan so quickly and flexibly, and it shows how our brains are wired to be incredibly efficient, to minimize the effort it takes to think and act. And looking forward, this could be a really powerful blueprint for building smarter, more human-like AI.
So, what this framework is really telling us is that our intelligence isn't just about raw processing power, like a computer. It's about having this incredibly elegant and efficient architecture. Our creativity, our ability to adapt and solve new problems on the fly, it all comes from having this predictive, context-switching mind.
And that leaves us with one last kind of mind-bending thought. If our reality is something our brain is actively building based on the context it thinks it's in, well, that gives us a powerful new lens to look at so much more. What happens when those contexts are wrong? When our predictive models lead us down the wrong path? It opens up a whole new way of thinking about everything from a simple misunderstanding between friends to deeply ingrained biases. It suggests that the reality we all experience is really just a story our brain is telling itself, one context at a time.